So far in Chapter 9, we've looked at quadratic equations in vertex form and in general form. This lesson, we're going to be looking at factored form, which looks like this. Y equals A, which is our stretch value, times x minus root 1 times x minus root 2. And root 1 and root 2 are just our zeros on our graph. And it doesn't matter which order, which one is root 1, which one is root 2. And we're going to be looking at the connections between factored form in the graph and also using rectangular diagrams to convert factored form to general form and vice versa. So example A gives us a graph and we are to write the equation for the parabola in vertex form, factored form, and in general form. And we are going to start with factored form since that is our new form this section. And if we look at our graph here, we have two roots. So we have one at -5 and we have one at 3. So when we write that in factored form, we to this point don't know what A is going to be, but root 1 can be 3, so x minus root 1. And then when we have an x minus a negative, it becomes x plus. So this is x minus a -5, or x plus 5. But now, to figure out what that A value is going to be, if we look at the graph of y equals x minus 3 times x plus 5, which would be an A value of 1, you would see that we've got a vertex of -16, a y value of -16 at our vertex, where in reality we need to be at -8. So we can calculate what that stretch value is going to be by figuring out what we have to multiply -16 by to get -8. So -16 times whatever our stretch value is will give us -8. Okay? And then solving for A, we divide by -16, divide by -16, and we get an A value of, simplifying -8 divided by -16, of 1/2, which you can also write as 0.5. So our final equation then is y equals 0.5, or 1/2, times x minus 3 times x plus 5. Now we already know how to write vertex form. Vertex form is going to have the same A value, and we get our vertex from the graph, which is -1, -8. And remember, vertex form is y equals A times x minus h squared plus k. So putting our values in, that's y equals 0.5 times x plus 1, because that's a minus a -1, squared, and minus 8 is our k value. Now there's two ways to get our general form. We're going to expand either our factored form or our vertex form. Okay, and it is up to you which one you do, but the one we've practiced up to this point is expanding vertex form. So that's what we are going to do just for this example. So we have 0.5 times the quantity x plus 1 squared. So if we set up our rectangle diagram, and then -8. So when we fill that out, x times x gives us x squared, 1 times x is 1x, and 1 times 1 is 1. So that's 0.5 times x squared. 1x plus 1x gives us 2x, and then plus 1, -8. Then we need to distribute that 0.5 to everything inside the parentheses, which gives us 0.5 x squared plus 1x plus 0.5. And then we bring down that -8. Now our last step is to combine our constants, and that will give us our final answer, 0.5 x squared plus 1x you can either write it as plus a negative or as minus 7.5. That is our general form. The other word for that is standard form. Both mean the same thing. Now, let's talk about how we know if all three forms are in fact different forms of the same equation. Well, the first thing we can do is we could graph all three as y1, y2, and y3 all on the same graph. And if they are the same graph, that would mean that we do in fact have all forms be in the same equation. The other way is to expand both vertex form and root form to make sure you get the same general form equation when you do so. So we've already expanded the vertex form into standard form, so now we can also expand the root form into standard form. So go ahead and take a moment here and expand our root form to get our general form equation. Now if you expanded that correctly using our rectangle diagram and then distributing the 0.5, you should have gotten the same general form equation, 0.5x squared plus 1x minus 7.5, which tells us all of our equations are in fact the same equation. Now go ahead and do the guided practice on your own, and when you are ready to check your work or if you need help, you can watch the next video for that.